Hello maths fans, Dr Tom Crawford here at the University of Oxford, and today I'm doing a Further Maths GCSE exam. The paper I'm going to be sitting is the 2019 AQA Further Maths GCSE Paper 1, which is non-calculator. I have a total of 1 hour and 30 minutes to answer all of the questions. As usual with this type of video, I have done zero preparation. I don't even know what's on the syllabus. I will be taking the exam completely blind, recording the whole thing for you all to enjoy. So let's get cracking. So you'll notice this time I'm actually going to be writing on the exam paper after the very harsh feedback from my last examiner, Ben Sparks, when I took the Maths GCSE exam. So hopefully this will be a little easier and go a little better than me writing on plain paper, particularly when it comes to those graphs. We've got the Further Mathematics Paper 1, 2019, time allowed 1 hour 30 minutes. And oh, we've got a formula sheet. It's very nice, telling me the volume of a sphere, surface area of a sphere, volume of a cone, surface area of a cone, sine rule, cosine rule, quadratic equation. We get the quadratic equation, that's generous. And some trig identities. Also very nice. Right, surname. Surname I can do. Crawford. Four names. Tom. Candidate signature. That's a new one. All right, signature. All right then, let's see what we got. So, question 1. Straight line passes through the points -2 and 11 and 1 and 2. Work out the equation of the line. Right, well, I'm going to draw a graph here. So first thing I'm going to do is draw a diagram, I think, just to make sure I have a feel for what's happening. So -2 for x, so that's going to be here, and 11 for y, so that's going to be up here. And then 1 for x and 2, like that maybe. 1 and 2. Okay, so if we kind of form this triangle with a right angle, this one is 3. We know the height has gone from 2 to 11, so it's 9. So therefore the gradient, so delta y over delta x is 9 over 3 is 3, and it's negative. So I think it's y equals -3x plus c, and then to work out c, let's try a point. So when x is 1, y needs to be 2. So 2 must equal -3 plus c, so c must be 5, and then let's just check that that makes sense for the other point. So I think the answer is y equals -3x plus 5. So then when x is -2, I get -2 times 6, so 6 plus 5 is 11, yep. And then when x is 1, yes, -3x plus 5, happy with that? Okay. Question 2. Right, 5 over 6a. Okay, 5 over 6a plus a over 4 as a single fraction. Okay, so we need to put them over the same denominator. So I believe that's going to be 5 times 4 is 20 over 24a plus, and then to get that one, 6a plus 6a squared over 24a. So it's 20 plus 6a squared over 24a. Give it in its simplest form. So I want to simplify some things. So I can say that's equal to 2 lots of 10 plus 3a squared over 12a with another 2 in front. So the 2's cancel. So I think that's as simple as we'll get, because 10 is 2 times 5 and 3 is prime. Yep. So I believe the answer there is 10 plus 3a squared over 12a. Cool. Okay. Much easier writing on the exam paper, I have to say. Thank you, Ben. Right, work out the smallest integer value of x that satisfies this inequality. Okay, so 8 minus 5x is less than 26. We want the smallest value. Sure, so let's subtract 8 from both sides. So I need -5x to be less than 18, which means I need x to be greater than, if I divide through by the -5, minus 18 over 5. So what's that? That's like 5 and a bit. So that's definitely greater than 3 and a bit. Sorry, 3 and a bit. So it's greater than 3. So I think x equals 3. Now let's just double check. Does that make sense? Minus 3. Apologies. X needs to be greater than minus 3. So x is minus 3. That's right. I'm going to write that one clearly for the examiner. So x is minus 3. So I think it's minus 3. So let's double check that makes sense. So 8 plus 15 is less than 26. That's correct. If x was a smaller integer, it would be minus 4. Then it would be 28, which is not less than 26. Cool. Happy with that one. Okay. Work out the values of p and k. Ooh, interesting. We have an identity. Good old triple equals. So if I expand this out, px minus p plus 6x plus 2k. We want this to be identical to 4x plus 8. Where p and k are integers. Okay. Interesting. So I've got a balanced term by term. So if we do order x, let's see where we're going with this. Then I've got p plus 6 on the left, and that must be identical to 4, which tells me that p is minus 2. And then if I look at the constant order there, then I've got minus p plus 2k needs to be identical to 8. So minus p is minus 2 is 2. So that's now 2 plus 2k is 8. So 2k is identically 6, which tells me that k must be 3. Okay, let's check it makes sense. So p times x minus 1. So minus 2. Annoying. Let's just expand that out. So if I had minus 2x minus 1 plus 2 lots of 3x plus 3. And they're both integers, which is good. So let's expand this out. So it's minus 2x plus 2 plus 6x plus 6. So I make that to be 4x plus 8, which is then what's in that bracket. Woo! Okay, cool. Happy with that? Doing well so far. Question 5. Ooh, cube root formula. Okay, so I'm going to start by cubing both sides. So 2 root x minus 10 must equal the cube of 2, which is 8. Right. So then 2, I see what we're doing this. So then 2 root x, if I now add 10 to both sides, must be 18. Root x is 9. So therefore x is 81. So I think x is 81. Does that make sense? Root x is 9. So I've got 2 times 9 minus 8, minus 10. Sorry, 2 times 9 is 18, minus 10 is 8. Cube root of 8 is indeed 2. Woo! Cool. The transformation. I didn't know we had matrices at Further Maths GCSE. I like it though, I like it. Transformation matrix maps the point 3, 4 onto the point 8 minus 7. So that means, I think, that 2ab minus a multiplied by the vector 3, 4, I believe should give me 8 minus 7. That would be the transformation. The matrix is acting on that first vector to give me the new one. I think that's how that's going to work. So I expand this out using matrix multiplication. So that's first row, first column. 6a plus 4b, therefore has to be 8. And then first row, second column, minus 3b minus 4a has to be minus 7. Simultaneous equations. Okay, how am I going to do this one then? So let's do the first one times 2 and the second one times 3. Sure. So that's 12a plus 8b. First one times 2. 12a plus 8b is 16. And then the second one multiplied by, what was I going to do this one? Times 3, sorry, to make the a's add up. So times 3 gives me minus 12a. Times by 2, yep. Minus 12a minus 9b is minus 21. So now if I add the two together, so add will tell me 12a minus 12a is obviously 0. 8b minus 9b is minus b. And that has to be 16 minus 21 is minus 5. So I believe b is 5 in there. See if this makes sense. So if b is 5, then in here I've got 6a plus 20 equals 8. So 6a is minus 12, so a is minus 2. Okay, so a is minus 2, b is 5. Let's double check, that makes sense. 6a, so minus 12 plus 20 is 8. Good. Minus 3 times b, minus 15 plus 8 is minus 7. Yes, happy. Right, question 7. We have a function, f of x is given by this. Complicated function. They're gonna make me draw it. Of course they are. With the grid, at least now I have the correct grid. Okay, I can do this. So, f of x is minus 2x when x goes from minus 1 to 0. So, minus 2x, let's just plot these. Minus 2x is a negative gradient that's kind of steep. Yes, like that. Okay, so I know that when x is minus 1, y should be 2. So it's that bit. Okay. First bit. X times 4 minus x, well, that's equal to a quadratic. So it's a quadratic, and we've got roots. It's a minus x squared. So it's an upside down, it's a hump-shaped quadratic, roots at 0 and at 4. So it wants to go through there, but it's going to stop at 3. So when x equals 3, y equals 3 as well. Okay, cool. I think that's right. 3 times 4 minus, yep. And it's going to go through there. So I think its peak is going to be when x is 2, y is 4. When x is 1, y is 3. And then it's going steep from 0, right? So it does that. Whoops. So we're going to about that last bit. Whoa, not the whole thing. I'm going to go up, loop through there. I'm going to do a single line, Ben. No feathering this time. Right. I think that's good. And then the last one, 2x minus 3. What does that look like? So the intercept is minus 3 and has gradient 2x, so it's going kind of like that. Excellent. So that means when x is 3, then y is equal to 6 minus 3, y is equal to 3. So it joins the same point. And then when x is 4, which is the last point I'm interested in, then y is equal to 8 minus, so y is equal to 5. So it goes up to here. And that's a straight line with a positive gradient. Okay, so it's straight line, negative gradient, quadratic, straight line, positive, I think. Now let's just check. That's a 2-1 gradient. Yep. Yeah, happy with that. Fun question. Like that one. All right, number 8. ABC is a straight line, not drawn accurately. They love saying not drawn accurately. They need to get new people to draw accurate sketches and curves, I think. ABC is a straight line. A is this point, minus 4, 5. C is the point 20 minus 7. Great. AB, BC are in this ratio. Fine. Work out the coordinates of B. Ooh. Interesting. Right, so I'm going to draw a sketch. Let's see. Which is also not drawn accurately. So I'm going from minus 4 to 5. So when x is minus 4, y is 5. Okay. And we're going down to this point 20, so really far over here. And then minus 7, so really far down here. And we want to connect these two with some line, sure, like so. Right, so let's work out, same as earlier question, let's try and turn this into a triangle and figure out the gradient. So, change in y is 24, because we're going, no it's not, ignore that, the change in x is 24. Change in x is 24, so it's 24 along the bottom. And then going up, we're going from minus 7 to 5, so that's 12 increase. So delta y over delta x is 24 over 12, which is 2. It's a negative gradient, so we know that y is equal to minus 2x. Intercept, when x is 0, I don't know, but I've got two simultaneous equations. Right, so I know that 5, so we know that 5 must equal minus 2, so must equal 8 plus c, so c should be minus 3. Very bad sketch, because that's y equals minus 3. Okay, very, very bad sketch. Anyway, doesn't matter. Does that make sense? And let's check the other point. So minus 7 equals minus 2 lots of x. So x is 20, so minus 40. Oh no, that doesn't work. Okay, double check this. Y must equal, c is minus 3, yes. So when x is 0, so I think it's that, minus 2x minus 3. But that doesn't work. Why doesn't that work? So we're definitely going 12 down and going 24 across. So it's 100% y equals, is it minus 2x? I've written in the wrong way round. Right, it's not 24 over 12. I was going to say this seemed too big. It's 12 over 24. Right, so it's 12 over 24. So it's a half x. Now this makes more sense. Now it makes more sense. It's x over 2 plus the c. Right. So it's x over 2 plus c. So let's go up here and erase this stuff again. So 5 must equal minus x over 2. So minus x becomes 4. 4 over 2 is 5 equals 2 plus c. So c is 3. So I think it's minus x over 2 plus 3. Check for the other point. So that's actually y equals plus 3. So it was a good sketch. Woo! Okay. Check the other point. So now when y is 20, so we need 20 equals minus, no, 20 is x. Very silly. So we need the x value. The x value is minus 7. So the x value is 20. The y value is minus 7. Minus 7 equals minus 10 plus 3. Tick. Yes. Okay. So that's my equation. Right. And now I want to know the point B is in this ratio 5 to 3. I probably didn't need the equation. Anyway, so I've got a 12 and a 24 triangle. If I divide, okay, so the length, I can do Pythagoras on this. So 100 and, okay, so 144 plus 24 squared equals the diagonal, let's call it z squared. And then I can work out the length of z and then hopefully divide by 8 and go 5/8 along for b. Fine. That's the plan. We'll see how it works. 24 squared. Okay, so 24 times 20 is 480. 24 times 4 is 96. So that's 576. Okay, so 144 plus 576 equals z squared, which has to then be, adding the 4 gives me 580, 627, 20. Okay, good. Z squared is 720. So z is the square root of 720. Oh, I don't know if that's a square number. I don't think it is. This is annoying. Must be an easy way to do this. Got it, I think. I don't actually need to know the length, I don't believe, because, so if we call this length, I'm thinking call the length diagonal z. So this has length z, then b is 3/8 of z. So if I similar triangle that, I think that will be 3/8 along here and times 3/8 along here. And that should be this, I think. So from the point C, instead of going 24 along, 1/8 would be 3, so we need to go 9 along. so it's going to be at 11. Okay, and then going up, we have gone 12, so that's 1.5, so that's 4.5. Up from minus 7 with 4.5, so that's 2.5, so minus 2.5. Okay, so I think it's 11. Okay, I think it's 11 minus 5 over 2. Now let's check that lies on the equation of my line, just because I already calculated it. Totally didn't need it, because I've calculated it. Does that work? So, and let's do a different colour. So when, let's check. So y, so that's my equation of my line, sure. So y equals, so I'm saying minus 5 over 2 equals minus 11 over 2 plus 3. Do I agree with that? I do agree with that. Yes, so B lies on the line. That makes me confident. Right, I think it's 11 minus 5 over 2. I did way more than I needed to there, but I think I've got the answer. All right, question 9. So circle the expression, I like this. So y, right, we know y is equal to 2x cubed minus 10x squared. Derivative then, y prime is equal to 6x minus 20x, 6x squared. 6x squared minus 20x. Woo! Okay, question 10. Factorize fully. Okay, 6x squared plus 26xy. Ooh, it's going to be an x and y in the brackets. Minus 20y squared. Right. So, we're going to need, is it going to be a 6 and a 1? Tricky to know. Let's try this. So we know we've got an x and an x and a y and a y. Right, and then 20, so 20 is 4 times 5, 2 times 10, or 20 times 1. And then 6 is 3 times 2, or 6 times 1. Right, and I need to make 26xy. So, that to me is suggesting 2 and a 10. And that's a plus, and it's minus the 20y squared. So I think maybe like a minus 2y. Maybe if we put a minus 2y and then a plus 10y. Okay, so that would give me plus 10yx minus 20y squared, which is what I want, when plus 10 of them, and then I need another 16 of them. Can I make another 16 of them? I don't think I can, so let's ignore that. So I need to make 26. So what's 26? So 26 is, I can do like a 6 plus a 20? Yeah. So if we did the 2 with the 10, okay, so 2x, yes, with the 10. And then we need a 3 and a 2. Might be the one. Let's check. So that's going to be 6x squared minus 20xy. So change the sign. Okay, plus 20xy minus 6xy. No, minus 20y squared. Okay, so it's not that. Because I need 30 minus the other 2, yes. Okay, we got there. Basically trial and error, but we got there. Okay, so we need 3 and 2. Right, let's check. 6x squared, yep. Plus 30 xy minus 4 xy minus 20y squared. Great. Okay, so the answer is 3x minus 2y times 2x plus 10y. Woo! 3 marks. Very harsh for 3 marks. Okay, question 11. Cones. So, I'm going to draw a diagram. So we'll start with cone. Very bad cone. Now, what do we know? We know that's R, we know this length is L, and then we know the height is H, okay? So the surface area is going to be 60 pi. We know that L is 3R. So I'm going to use that formula for the surface area. So let's find that. Where are you? There we go. So curved surface area of cone, pi r L. Ooh, just the curved bit. Is that what I've been given? Let's check. Pi r L. So if I go back to my question. So if the curved surface area is pi r L. Yes, curved surface area, good. So curved surface area, which is pi r L. But L is 3r, so that's 3 pi r squared. So therefore 3r squared is 60, which means r is the square root of 20, which is 2 root 5. Cool. And then I need to know h. So that's a triangle. So we've got this one's L, which we know is 3 lots of r, so that's 6 root 5. This is 2 root 5. So Pythagoras tells me that 2 root 5 squared, so 20, plus the unknown h squared has to equal 6. So 36 times 5. Wow, 36 times 5 is 180. So h squared is 160, which means h is great for root 10. So h is 4 root 10. Cool. And it says give your answer in a root 10, where a is greater than 1. Sounds right to me. Okay, question 12. Right, curve has equation. Y equals x cubed plus ax squared. Right, y equals x cubed plus ax squared minus 7. The gradient of the curve when x equals 4. The gradient of the curve when x equals 4 is twice the gradient. Okay, so dy by dx at x equals 4 is twice the gradient, 2 times dy by dx when x is minus 1. Work out the value of a. All right, well, I'll just solve that. So what is dy by dx first? Dy by dx is going to be 3x squared plus 2ax. So when x equals 4, so y prime at 4 is equal to 3 times 4 squared, 3 times 16, 48, plus 2a times x, so plus 8a. And that has to be equal to twice the gradient at minus 1. So 2 lots of gradient minus 1. 3x squared, so 3 minus 2a. Because it's plus 2ax, so minus 2a. Excellent. So that tells me now that those two have to be equal because that was y prime at minus 1. So let's solve them. So 48 plus 8a is equal to 6 minus 6a. So that means 42 is equal to minus 2a? No, that's wrong. Minus 14a. 42 is equal to minus 14a. 42 is minus 14a, right? Minus 6 on both sides and minus 8 across 8 and 6. Yep. So therefore 14a is minus 42. Let's be safe. So a is minus 3. Okay, so I think a is minus 3. Let's check the equation works. So we've got 48 minus 3 lots of 8, so minus 24, needs to be equal to 2 lots of 3 plus 3. Wait, 3 minus 2, so 3 plus 6, 2 lots of 9. That doesn't seem right. It's not 6a. That's why you should always check your answers. It's minus 4a. So let's just do that again. So I got a nice answer, but it was wrong. So it's that minus 4a. That was a silly mistake. So therefore 42 equals minus 12a. Fine. So a is minus 42 over 12, which I believe you can cancel. How many 12s go into that? 3.5 of them. So 7 over 2? 7 over 2, minus 7 over 2. So a is minus 7 over 2. Check that makes sense. In red again. So 48 minus 8 lots of that. So that's minus 4 lots of 7. So minus 28. And I need that to equal 2 lots of 3 minus 2, 3 plus 7. Excellent. Whoops, not 70. 7. 8 plus 7, which equals 20 on both counts. Yes. Okay, a is minus 7 over 2. Right, 13. Where are we going next? It's an inequality. Okay. 4 marks. Prove that something minus this is positive. Ooh, proof question. I like this. This is good to be doing proof questions. GCSE. Okay, so if this is going to be true, then what can I say? We can say 3x plus 5 squared must be greater than or equal to what we're subtracting, which is 5x times x plus 10. I think I'm going to expand everything before I do any square roots. So if I square this out, I'm going to get 9x squared, then it would be plus 15x, so plus 30x plus 25 needs to be greater than or equal to 5x squared plus 50x. Sure. Now, so that gives me 4x squared minus 20x plus 25 must be positive. Is that right? 30, subtract 15 both sides. Yeah, subtract 5x. Okay. Does that factorize? It looks like it might. So I think it's a 2x plus 5 times, no, sorry, 2x minus. It's going to be a 2x minus 5, isn't it? 2x minus 5 times 2x minus 5 must be positive, I think. So let's check. So that's, expanding that out, 4x squared minus 10x minus another 10 plus 5. Yeah. So you're saying, so this is if and only if this is true, if and only if this is true, if and only if this is true, if and only if 2x minus 5 squared is positive, which is now clearly true, since square number. Smiley face, QED. Woo! Okay, number 14. Matrices again, okay. Fun fact for you all, I had never studied or seen a matrix until I came to university. Because when I did, that's why I'm amazed it's in GCSE level. When I did Further Maths A level back in 2008, summer of 2008, matrices was only covered in Further Pure 3, which was an optional module. So I instead took extra statistics because I really enjoyed statistics. So I never actually had seen a matrix until my first linear algebra lecture, and the lecturer just starts writing this magical table of numbers on the board, and I was like, what's going on? So I had to basically go home and learn Further Pure 3 in like a week, just got a textbook and just did it all, and then I was able to follow what on earth was going on in the lectures. So it's amazing and really, really important and valuable, and I'm really glad to see it, but it is amazing that matrices are now covered in GCSE lessons. You're all lucky because they're so important, so important tools for solving all kinds of maths and science problems in general. Anyway, back to the question. So 90 degrees clockwise about the origin. So we're starting wherever, and then we're going clockwise, so that's going that way. So we want to go by minus pi by 2. Right, so I'm going to start by writing down the general formula for a rotation matrix, if I can remember. Which I think, oh god, it's cos theta, sine theta, and then we do put them, no, minus sine theta there, sine theta, cos theta, and this is a rotation matrix by theta anti-clockwise. So go clockwise and go minus pi by 2, yes. So now when theta is pi by 2, okay, then I'm going to get 0 minus pi by 2. Sorry, theta is minus pi by 2. Cos is 0. Sine is 0 is negative. So minus sine becomes a 1. Yeah, so that one's 1. That one's minus 1 and 0. Awesome. So I think that's A. Now B. Okay, now B is a reflection matrix. So this is similar, but you swap a couple of the things. So cos theta, sine theta, and I want to say minus cos theta, I think. That's definitely got determinant -1, so I'm going to go with that. Now, this is a reflection in the line with gradient theta over 2. So here I want y equals x, which has gradient 45 degrees, so that needs to be pi over 4, so theta is pi over 2. Right, so therefore b, right over here, so that needs to be that. So b is cos of pi by 2, still zeros, but now you've got a sine of pi by 2, which is the ones. Right, so 0, 1, 1, 0, I think. Now, when we apply these, so we want to do a first, so we want to import a vector x, apply a, and then apply b. So I want b times a. Okay, so ba is the matrix I want, because then a is first and then b. Good. So that's going to be 0, 1, 1, 0 times a, which is 0, 1, minus 1, 0. Okay, it's just multiplication time. First row, first column is -1. First row, second column is 0. Second row, first column is 0. Second row, second column is 1. So I think it's -1, 0, 0, -1. Interesting. So I think my answer is -1, 0, 0, 1. But I'm going to check it because there was quite a lot involved there, and I'm not entirely convinced. I think they're the right matrices, but let's just check. So if I start at 1, 1, then I go down to x is 1, y is -1. We rotate that 45 degree, 90 degree angle. Yep. Then I would reflect, so I'm going to end up at -1 and y is 1. So x is -1, y is 1. Right. So let's check. So if I do -1, 0, 0, 1 times 1, 1. First row, first column is -1. Second row, second column is 1. Yes, smiley face. I'm happy with that. So I think that's the matrix. Okay, number 15. A lot of questions. Okay, here's a sketch of y equals cos. Good. We're given the cos of 36 degrees. 0.8090. Solve cos of x equals minus. Okay, so cos of 36 degrees then is about here. So when is cos equal to minus that? Sort of here. So 36, so 180 minus 36 degrees, be 144 degrees. And it's also going to be at that second point, which is 180 plus 36, which is 216. So I think there are two answers. So I think x in that range. Yep, two answers in that range. So I believe that x equals 144 degrees or 216 degrees. Question 16, surds. Of course it is. Right, you can do surds. So 21 minus 11 root 5 we multiply by the opposite there. So that's 3 plus root 5. The denominator is a difference of 2 squares. 3 squared is 9. Root 5 squared is 5. 9 minus 5 is 4. All right, so that's 4. So quarter times 63 plus 21 root 5 minus 33 root 5 minus 55. 5 times 11, yep. So that's a quarter. 63 minus 55 is 8. Minus 12 root 5. And they're all going to divide by 4. Perfect. So 2 minus 3 root 5. Answer 2 minus 3 root 5. Definitely in its simplest form. Okay, number 17. Oh no, circle theorems. It was always going to be circle theorems, wasn't it? Oh, Jesus. Okay. All right, what are we trying to do? Maybe this is what I can remember. Had to be circle theorems. If you don't know what I'm on about, go and watch me doing the standard GCSE higher exam because I don't know circle theorems. So this is going to be entertaining. Right, I'm just going to have to get stuck in, aren't I? Okay, stop stalling, Tom. Okay, A, B, and C are points on the circumference of a circle. ECD is tangent. Okay, so I know if I went to the centre, that would be a right angle. I'm going to add that in. So I know that there. is a right angle. I know that circle theorem. Okay, angle AOB is 2x plus 46 degrees. OBC is 37 degrees, and ACD is that. Okay, now this is nice because I know lots of things straight away, actually. This isn't that bad, he says. Let's see, getting ahead of myself. So this one in here is also 37 degrees because it's an isosceles because of them both being radii, both a radius of the circle. So that's 37. So I know the angle here. So the angle in the middle is, so 37 plus 37 is 74. So 180 minus 74 is 106 degrees. So that's 106 degrees. Okay. Now, what else do we know? I know, what can we work out? So I can now work out this angle. So that's 360 degrees minus 2x plus 46 minus 106. Excellent. Okay. So this is 360 minus 106 would be 254. 254 minus 2x minus 46. So that's 208 minus 2x, I think. Okay, so that one there is 208 degrees minus 2x. Now, and I know that that last angle there is 90 minus 3x. Which means this one, because it's also radius, is 90 minus 3x. So I now know that 208 minus 2x plus 90 minus 3x plus 90 minus 3x has to equal the total in the triangle, which is 180. Excellent. So that means 208 minus, so cancel, 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 minus 8x is 0. 8x is 208, so x is 208 over 8. So what's that? That's 104 over 4, which is 52 over 2, which is 26. 26 degrees is x. Assuming I had to find x. Yes, right. So I think x is 26 degrees. Oh, fingers crossed, and maybe have some confidence in a circle theorem question. We'll see. Okay, question 18. Can't be that many more left. Okay, trapeziums. ADEF is a trapezium. ABC is a straight line. BCEF is a square. Okay, so they're all root 6, root 6, root 6. So the AB is root 2. Interesting. That's trigonometry. So I know that, so I've got AB, which is the adjacent side, let's call it A. And I've got the opposite. So I know that tan of 60 degrees is opposite is root 6 over A. Now what is tan of 60 degrees? I believe it's root 3. So tan of 60 degrees is a known value is root 3. So therefore A must be root 2. Cool. Yeah. Okay. Assuming tan of 60 is root 3. Do I believe tan of 60 is root 3? It's sine of 60 over cos of 60. That would make sense. Yeah. Okay. Cool. Right then. So that's root 2. Show that DE is 2 root 6. Okay, where's DE? Okay, so let's call this one, let's call this Y. So I now know similar idea then, don't I? But except it's 30. So I know that tan, no, it's not tan because I want the diagonal. My bad. So I know that I've got the adjacent, I've got, no, I've got the opposite, O and H, cos. Silly old Harry, soccer, silly old Harry. So I know that sine of 30 degrees is opposite of adjacent, so root 6 over Y. But what do I know sine of 30 degrees is? Let's draw the graph really quickly. Sine of 30 degrees, so I know that that's 90. It's quite small then, isn't it? So sine of 30 is a half. Yeah, so therefore y equals 2 root 6. Yes, cool. Good. Work out the perimeter of the trapezium. Oh, okay. So what have we worked out here? So we worked out y. So we know this is 2 root 6 along here. We worked out AB as root 2. Great. Okay, so I need to know 2 unknown values then, aren't there? We need to know this one, and we need to know this one. Okay, great. Now this is a right angled triangle, so let's just say root 6 squared, so 6 plus, let's call it z. 6, because of the square, Pythagoras. 6 plus z squared has to equal 4 times 6, 24. Z squared is therefore 18. So z is root 18, which is 3 root 2. Right, root 18, that's root, oh, we take a 9 out because that's a 3, yep. So z is 3 root 2. And then the only other one I need to know is this. So let's use Pythagoras again. So we've got root 2 squared, so 2 plus 6 equals, let's call it x squared, where this is x. So x is root 8, which is 2 root 2. Okay, so total perimeter then. So total perimeter. So what have we got? Start at the bottom left. So we've got root 2. Let's do this one back in black. So we've got a root 2 plus a root 6 plus z, where I've worked out z to be 3 root 2. And then we've got a plus 2 root 6. And then we've got a root 6 and a root 2. Plus 2 root 2. So there are 6 pieces. Let's check that makes sense. 1, 2, 3, 4, 5, 6. Good, I agree with that. So if I simplify all of this, a root 2 plus 3 of them plus another 2 of them. So that's 6 lots of root 2. And then I've got a root 6, 2 lots of root 6 plus 4 root 6. So 6 root 2 plus 4 root 6. So in other words, i.e. t is 6 and w is 4, I think. Okay, now 19. Function question. Okay, so f of x, what have we got? F of x is x minus 3 over 2x. Solve. Ooh, this is nice. This is like an interview admissions question that my colleague Oliver Riordan used in interviews recently. We did this in the video with Mike Boyd where he takes the Oxford interview, which if you haven't watched, totally go and watch. It's a real interview with various actual admissions tutors, myself included, and I train Mike and we work a little bit on how he can improve his interview performance. But it's very similar, this question here, it's very similar, the kind of thing that Oliver actually asked Mike in that interview. So do check it out. However, I'm getting distracted again. So f of x is this, solve this. Well, what is f of x plus 1? Let's do that first. So that's x plus 1 minus 3 over 2 lots of x plus 1. Great. What's f of 2x? Well, that is 2x minus 3 over 2 lots of that, so that's over 4x. So therefore, f of x plus 1 minus f of 2x has to be x plus 1 minus 3. So plus 1 minus 3 is x minus 2 over 2 lots of x plus 1 minus f of 2x, so minus 2x minus 3 on the top over 4x. Okay, and we want to solve that equal to a half, so we'll do that in a minute. So simplify it. That's 4x times x minus 2 minus 2x minus 3 times 2x plus 2 all over 4x times 2x plus 2. Okay, it's going to be 2 is going to cancel, but I'll just leave it like that for now. So 4x squared minus 8x minus 4x squared, nice, 4x squared plus 4x minus 6x minus 6 all divided by 4x times 2x plus 2. Okay, so what are we going to cancel then? So 4x squared minus 4x squared. Right, so that's going to be that. So what I think this will simplify to is minus 8 minus another 4x gives you minus 12, but then plussing another 2. So inside here is minus 2, so plus 2, so minus 6x, I think. Right, because it's minus 8x, minus another 4 gives you minus 12, and then I'm adding 6x. So minus 6x plus 6. So it's minus 6. Yeah. Minus 6x plus 6 over 4x. So I can definitely cancel the 2. 4x times 2x plus 2. Right. So that's minus 3x plus 3 over 2x times 2x plus 2. Right, and I've got to solve that. So I think what I need to solve then is minus 3x plus 3 over 2x plus 2 needs to be half, was it? Needs to be a half. Okay, cool, we can do that. Great. So, multiply both sides by 2, so it's minus 3x plus 3 equals, multiplying up by the 2x, so you get an x times 2x plus 2 on the top, and then those 2's cancel. Excellent. So minus 3x plus 3 equals 2x squared plus 2x. So then you're going to get 0 equals 2x squared plus 5x minus 3. Is this going to factorize? Well, probably. So let's see, 0 equals, so you've got to have a 2x, and you need an x, and we need a 3 and a 1, maybe a plus 3 and a minus 1. I think will work. And a minus 1. And let's check. Always check. So that's 2x squared plus 6x minus x minus 3. Yes. So I think the answers then are 2x equals 1, so x is a half, or minus 3. Woo! End of questions! Amazing! Wasn't expecting that. Right, there are no questions printed on this page. Okay, great. Additional page if required, additional page if required. Okay, scroll all the way down. I'm not going to miss a question like Ben. Yeah, that's it. Okay, Further Maths GCSE done. Let's see how I did. Right, didn't mind that. That was actually quite enjoyable. Maybe it's just because I'm a mathematician and I just clearly love solving maths problems, but that was genuinely quite pleasant, quite relaxing. Couple of little bits and pieces there, but I feel relatively confident. You know, maybe this could be 100%, maybe. Fingers crossed. We'll have a look at the mark scheme now. And again, this is going to be in the video description, so you can check this, convince yourself I'm not cheating here. You can see everything I've written. So I'm going to go through this. I've got it on my computer in front of me, and I'm going to go through a mark according to the mark scheme, and let's see what I would have got. So question 1, the answer there is minus 3x plus 5. What have I got? Minus 3x plus 5. Right, so that's 3 marks. Excellent. So 3 out of 3. Okay, question 2. What's the answer here? It is 10 plus 3a squared over 12. 10 plus 3a squared over 12. Excellent. So that's 2 for that. So 2, and then out of... Okay, cool. Yep. Number 3, the answer is... what am I trying to get here? Answer minus 3. X is minus 3. Excellent. So that's 2 for that. Question 4 is P is minus 2 and K is 3. Great. And that would be 4 marks. P is minus 2, K is 3. 4 marks. Excellent. So that's 4 plus 2 plus 2. So that's 8 out of 8. So that's good. That's what we want. 8 out of 8. Looking good. Number 5, X is 81. Scores 3 marks. Excellent. 6, solving for these transformations. We got A is minus 2 and B is 5. A is minus 2, B is 5. Brilliant. 5 marks. Number 7. Oh, the fun graph one. So coming down, loop-de-loop, and then up. Beautiful. Right, 4 marks then I think. I've got, looks the same to me. So that's so far so good. 100% in. Right, number 8. What am I trying to get here? 11 and minus 2.5. I think that's what I got. 11 minus... That was the one I wasn't too sure about. Okay, that's good. Right, 4 marks for that. Number 9. What are we trying to get here? 6x squared minus 20x. Does that sound right? 6 squared minus 20x. That was differentiation 1. Yeah, cool. Factorize fully for 10. I'm not happy. Now this, so I understand this, but this is nonsense. I'm sorry. Maybe I'm just annoyed because this is going to be possibly the only mark that I drop on this, but this is ridiculous. So this is factorized fully. So I've written 3x minus 2y, 2x plus 10y. Now you only get 2 out of 3 marks for that because they want the 2 to be out the front. So what they wanted here was 3x minus 2y, x plus 5y, and then a factor of 2 out the front, which to me is a little bit over the top, and I don't think I can get that. No, must have 3 correct factors. I'm not happy, but fine. So that's 2 with a minus 1. So I'm going to get 7 out of those 8 first drop marks. But I'm not happy about it, but I'll follow the mark scheme. I've dropped a mark. Though my answer wasn't wrong. That's the key thing. Wasn't wrong. And I'm standing by that. Right, the cone question. H is 4 root 10. Excellent. 5 marks for that. Number 12. What are we doing here? A is minus 3.5. Yes! Okay, this is looking good. That's 5 there. So I'm going to get, 10 out of 10. Awesome. Okay, question 13. Where are we? Oh, the proof one. Right. So you rearrange to get as a square, like so. Right, so it should turn into 4x squared minus 20x plus 25, yes. And then you can factorize that, can you not? You can. Brilliant. So as long as I write it as 2x minus 5 squared, I've written that. And then I've said because it's positive to square. Brilliant. 4 marks. 40. Ooh, matrix. This one was, yeah. Okay, let's check. A is 0, 1, minus 1, 0. Good. I got my matrices right. And then B is, come on, B, where are you? B is going to be 0, 1, 1, 0. Yes. And then the product is BA, which I think I did, which is minus 1. Get in. I'm happy. Yes. I'm very pleased with that one. Right. So that's 4 for that. And I got 4 above. Yes. So that's 8. Amazing. Okay. Sketch 144, 216. Tick and tick. Beautiful. 2 for that. Next one was 2 minus... yeah, this one. Yep. Cool. 4 marks. That was a nice generous 4 marks, that one. Maybe it's just because I'm used to difference of 2 squares and things, but generous. 17x is 26. Ooh, circles. That might be right. There it is. I hope you're all watching. Everyone who said I can't do circle theorems, which I still can't. But there you go. I did a circle theorem question. X is 26 degrees. 4 marks and a super smiley face because I'm super psyched about that one. Oh, wow. Okay. This is looking good. Near the end now. 18 is over tan 60, which was root 3. Yep. 1 mark for mentioning tan 60 is root 3. Good. Second one, use of 1, 2, root 3 triangle, or knowing sine 30 is a half. Brilliant. 1 mark. And then the trapezium perimeter, come on, 6 root 2 plus 4 root 6, 6 root 2 plus 4 root 6. This is going so well. Right, 3 marks, so that's 5 out of 5. And then the last question. It's going to be that simplify one, isn't it? What are we trying to get here? Okay, so the answers, so we substitute, we rearrange, we solve for a half and minus 3. Get in. X is a half, and X is minus 3. Big tick. That was for a total of 6 questions. That's 6 out of 6. So I've dropped a single mark. So if I go right back to the beginning, I'm going to write this on to see. So the total number of marks is 70. So I have, of course, I got 69. I have 69 marks out of 70. That's why I didn't get 70. I got a better score than 70. I scored 69. Right, there it is. A full Further Maths GCSE exam done completely blind. I tried to explain what I was doing. I've talked you through the mark scheme. Hopefully we're all happy with my really nice score there, 69 out of 70. I hope you found it as entertaining as I did doing the actual exam. That was genuinely a lot of fun. I hope you've enjoyed watching this. I had a lot of fun making it. I am going to keep making more exam-based videos, so do keep sending in your suggestions. As you can tell, I have a blast making these, so as long as you all keep enjoying watching them and sharing them, then I'll keep recording the videos. So thank you as always for watching. Please do remember to subscribe to the channel if you've enjoyed this, and I'll see you all soon. Take care.